Every second, trillions of invisible particles are passing through your body. They stream through the Earth itself, through oceans, mountains, even the densest metals, without leaving a trace. Scientists call them neutrinos, but their elusive behavior has earned them a much spookier nickname, the ghost particles of the cosmos. Section 1. Introduction. Neutrinos are among the most mysterious particles in the universe. Unlike protons or electrons, they don't carry electric charge. They don't interact with the electromagnetic force. Instead, they interact only through gravity and the weak nuclear force, the faintest of nature's forces. That's why detecting them is incredibly difficult. At first, scientists believed neutrinos had no mass at all, but experiments later revealed they do. Though so tiny, it remains almost impossible to measure. And because they move at speeds close to that of light, neutrinos act as messengers, carrying information across the cosmos. Section 2. The origin. Neutrinos were born in the very first second after the Big Bang, long before light itself could freely travel through space. That makes them even older than the cosmic microwave background radiation. Detecting these ancient neutrinos could open a window into regions far beyond our observable universe. And they're still being created today, in the heart of stars, in supernova explosions, and even in the violent cores of galaxies powered by supermassive black holes. Some of them may have traveled billions of years, just to pass through you, without you ever noticing. Section 3. The discovery. But how did we even discover such ghostly particles? Back in 1930, physicist Wolfgang Pauli faced a troubling mystery. In beta decay, electrons emitted from atoms showed a strange, continuous energy spectrum, something that seemed to violate the sacred law of energy conservation. To solve this, Pauli proposed a radical idea. Perhaps an invisible, neutral particle was carrying away the missing energy. This unseen particle was later named the neutrino. It was a bold hypothesis, and decades later, experiments finally proved Pauli right. Section 4. Neutrino oscillations. But the story didn't end there. Neutrinos are even stranger than Pauli imagined. They come in 3 flavors: electron, muon, and tau neutrinos. Here's the twist. As neutrinos travel through space, they oscillate, switching from one flavor to another. Drop 3 stones into a lake at slightly different times. Initially, the waves align in a distinct pattern, but as they move forward, some waves advance faster while others lag. Similarly, neutrinos shift flavors as their mass states fall out of sync. Sometimes an electron neutrino appears as a muon neutrino, or even a tau neutrino. This quantum dance has been confirmed by experiments and remains one of the strangest features of these ghostly travelers. Section 5. The Majorana mystery. And then comes the mind-bending question. Are neutrinos their own antiparticles? Most particles have opposites, like the electron and its positive twin, the positron. But neutrinos might break this rule. If they are Majorana particles, then neutrinos and antineutrinos are one and the same. Physicists search for this answer through a process called neutrinoless double beta decay. If discovered, it would revolutionize particle physics and possibly explain one of the greatest mysteries of all: why our universe is made mostly of matter, and not antimatter. Section 6. Why neutrinos have mass. Particles get mass through the Higgs field, but neutrinos don't directly interact with Higgs field. Then why do they have mass? One possible explanation is the seesaw mechanism. According to this theory, neutrinos come in 2 types: light neutrinos, the ones we can detect, and hypothetical heavy neutrinos with gigantic masses. When the two mix, the heavy neutrinos push the light ones into having incredibly tiny masses. Like a seesaw, the heavier one pushes the lighter one almost weightless. And these heavy neutrinos, if they exist, could also explain why matter triumphed over antimatter after the Big Bang. Section 7. Neutrinos and the mystery of dark matter. But neutrinos may also hold the key to another cosmic puzzle, dark matter. Some scientists propose the existence of sterile neutrinos, a type that doesn't even interact through the weak force, only through gravity. These sterile neutrinos could be the very substance of dark matter. If they exist with just the right mass, they'd move slightly faster than traditional cold dark matter particles. That would help solve a long-standing mystery known as the missing satellite problem. According to simulations, galaxies like the Milky Way should have hundreds of dwarf satellite galaxies. But we only see a few dozen. Sterile neutrinos, moving fast enough to smooth out small structures, could explain this cosmic discrepancy. Section 8. Closing. From carrying whispers of the Big Bang to shaping galaxies, neutrinos are among the strangest and most important messengers in the universe. They are everywhere, yet almost impossible to catch. They may even explain the very existence of matter itself. Invisible, nearly massless, and ghostly, neutrinos remind us that the universe still hides secrets beyond our imagination. And the next time you look up at the night sky, remember, countless ghost particles are passing through you, carrying stories from the edge of the cosmos. If you enjoyed this journey into the world of ghost particles, don't forget to like, share, and subscribe for more explorations of the universe's greatest mysteries.